In this video, we'll do a quick example that makes use of the fundamental theorem of calculus. We'll find the area under the curve y of x equals x minus 2 times x plus 2. And we know that if we draw that, it's going to be a parabola that intercepts the x-axis. That intercepts the x-axis at x equals negative 2 and x equals positive 2. So here's negative 2, here's positive 2. Okay, now suppose I want to calculate the area under that curve from x equals 2 to x equals 3. So this pink area. Well, we know from the fundamental theorem of calculus that the way to do that is to actually calculate a of 3 and then subtract a of 2, where of course a of x is the antiderivative or area function of y of x. And in this case, that's the same as the antiderivative of, well, we better expand this out. So we know from algebra that this is the same as x times x, or x squared, x times x, which is x squared, minus 2 times x, so minus 2x, plus 2 times x, so minus 2x plus 2x, those two middle terms cancel, and then it's going to be negative 2 times positive 2, which is going to give you negative 4. So this is the same as finding the antiderivative of x squared minus 4 dx. And this pink area that we're finding, we can actually write a of 3 minus a of 2 in a different way. We write it like this. So it's got the same symbol as the antiderivative, except we're going to put numbers on it. So the smaller number, the smaller value of x goes at the bottom. So we're starting at x equals 2, and then the bigger value of x goes up the top, and we're going to x equals 3. So we're going from 2 to 3, integrating the function x squared minus 4 dx. And this is commonly called the definite integral. The definite integral. When you're finding an area, it's called the definite integral. Another name for antiderivative, just to go with this, is the indefinite integral. So you're using the indefinite integral when you do the definite integral because you have to calculate the area function anyway before you put your values in. All right, let's go ahead and work this thing out real quick. So we've got the definite integral from x equals 2 to x equals 3 of the function x squared minus 4 dx. Well, we know that that's the same as a of 3 minus a of 2. So really all we need to do is work out this area function and then put in the value x equals 3 and then the value x equals 2 and subtract the second from the first. Let's go ahead and work out the area function. We know that we need to use the reverse power rule. So we add 1 to the power. So it's going to be x to the power of 3. 2 plus 1 is 3. And then we divide by the new power. Divide by 3, and then minus, and what differentiates to 4? Well, 4x differentiates to 4. So it's going to be minus 4x. And now normally at this point, we would add on a c. We would add on a constant, right? I would say plus c. But observe that we're going to be, well, the c doesn't depend on the x at all. And we're going to be subtracting a of 2 from a of 3. So really, we're just going to have plus c minus c. So there's actually no point in writing that c in there. So we're not going to. Okay, so now that we've written out our antiderivative function without bothering to put the value of c on, put it in a box kind of thing like this. And then at the lower end of the box, write 2. At the upper end of the box, write 3. So this is the definite integral from 2 to 3. of the function y of x, now that we've calculated the antiderivative of y of x, that is. So now what this means is that we take the thing inside the box, and we put in 3, x equals 3, so we got 3 to the power of 3 divided by 3 minus 4 times 3. And now we go minus, I'll do it down here, minus, and then we do exactly the same thing except we put 2 instead of x. So we get 2 to the power of 3 divided by 3 minus 4 times 2. Okay, now all we got to do is just expand all of this out. Notice that I have brackets around this part because we're subtracting the whole thing with 2 put inside. So when I expand it out, actually this negative and this negative are going to make a positive. So be careful with that. You have to subtract the whole function. Okay, so 3 to the power of 3, so we got 27 over 3 minus 4 times 3, so minus 12, minus 2 to the power of 3 is 8, so minus 8 over 3, and then it's going to be minus negative 8, so that's going to be plus 8. Okay, well, 27 over 3 minus 8 over 3 is 19 over 3, and then negative 12 plus 8 is negative 4, which is the same as negative 12 divided by 3. And so that's equal to 7 over 3. And that's the same as 2 and 1/3. Because 3 goes into 7 2 times and then 1/3 left over. 2 and 1/3. And I've been lazy in my working. I haven't bothered to write any units. But for the final answer, I really should include a unit. Units squared, because we're dealing with an area. Remember, when you're calculating a definite integral, you're calculating an area. In fact, we calculated this pink area right here. Area equals 2 and 1/3 units squared. All right, that's it. Thanks very much for watching. See you guys later. Bye.